Good morning. Thank you for joining our session, Air Traffic Control Speaks Cloud Native. What you're seeing here on this big screen is actually our product we are talking about today. This is Phoenix Web Innovation. This is the main tool for air traffic controllers to maintain minimum separation between aircraft and to operate flights safely and efficiently. Today, we would like to give you an insight in the technical journey from our legacy product, Phoenix, towards a cloud-native one, and talk a little bit about the requirements, technology, and also about the challenges we faced during this journey. My name is Christian. I've been working for the DFS Group for almost 20 years, and at the moment, I'm responsible for our cloud team and developing such products.
Thank you very much. Microphone is on. Thank you very much, Christian. My name is Florian. Welcome to our slot. I'm Technical Sales and Business Development Manager with Sys11. So all of you guys here are obviously deeply into technology, and everyone is putting value to the community here. What we'll see today is what happens if we use this community and what is available on the marketplace. So therefore, I want to say a big thank you, Christian, that you share some details with us. Of course, it won't be all of them, but we all get in contact with this directly or indirectly, either way. So a little bit about us, about Sys11. We already have 15 years experience in operations of setups. Of course, not all the time with Kubernetes, but this is what's happening right now. And as part of Secunet, we have more than 1,000 experts all across Germany, all across Europe, and further on. Luckily, we have access to our own network across Europe, and I will get into detail with that later on. The focus is Metacube, that is a CNCF-certified product for Kubernetes as a service and management and operations within this solution. So our main focus is to get things automated and make operations easier. And this is what we'll see today.
So who are we? We are the DFS Aviation Services. We are a 100% subsidiary of DFS Deutsche Flugsicherung, which is the air navigation service provider within Germany and responsible for the safe operations of flights within Germany. We are also a certified air navigation service providers. That means we are holding a certification to provide air traffic services, and we are operating 9 regional towers within Germany, 2 within Great Britain, and also operating the air traffic control within Bahrain. We have roughly 350 employees, 150 controllers, and mainly 50 person working in IT. Our business portfolio ranks from air traffic services, so this is more or less our main business, but also we are providing aviation training, consultancy services, and that's the area where I work in engineering and systems development. And the product which I've shown at the beginning, so this is one of our main products, which we provide to customers all over the world, from Brazil to Kazakhstan, from Canada to Thailand, so more or less all over the world. For that, we have several branches with a headquarter in Langen. This is close to Darmstadt and Frankfurt. We have branches in Bahrain, as I already said, Vienna, Beijing, and Peking. So how our journey started. We had a customer request to develop a web-based product to support a mobile use case for some of the airports, which is the original one was Hamburg. That's where the request came from. To develop a system, we sat together with our management team and also all the IT guys to discuss what kind of requirements should go into this development, because for us it was completely new. We had no knowledge within web technology, no knowledge within cloud, but just within all the ATC products. So we formed a team of a cloud provider, which is Sys11, and another company famous for web technology, and also brought a designer into the team. Because we said we not only want to develop a web-based product, but also want to change some things from our legacy product into a cloud-native one. Because we wanted to create a new business case at the end with a software-as-a-service product. In former times, we used just bare metal on site. So all the installations had to be on site at the customer with a lot of hardware, server, client architecture, KVM extenders, and all that kind of stuff. So we wanted to create a new system architecture towards a service-oriented architecture. We had the idea to form a new intuitive HMI. So that was the reason why we worked together with a designer. In former times, the HMI was more a form follows function. So everything which the controller wanted to have with a functionality was just developed and created by a developer themselves. So that was completely different. For this approach, we decided to use an agile development approach. This was also completely new for us, because usually we work with a waterfall model, just a sequential order, creating requirements at the beginning and having the product at the end. So here we started a completely new approach. And we decided to reuse some of the technology. Especially some of the core parts of the old legacy system was quite of importance for us, because this was a major thing selling to all our customers. And this was the tracker. So this calculates a position of a flight if you take raw radar data from radar stations and calculate the position of a flight. That sounds a little simple, but if you have to merge several sources from several different sensors, that's quite a thing. So we decided to have a requirement to reuse some of the old technology, but keep the same performance of the old system, or even improve it with the new technology. We wanted to have a cloud-ready product. At the beginning, this was just like a buzzword for us, because we had no knowledge how to operate a system within a cloud environment. So that's why we searched for someone with a lot of technology in this area, and this was Sys11 here. And with the product, we had some other targets in mind. So we said, okay, it should not only be used on site, but create new use cases. For example, use a radar screen as a mobile version somewhere in cars or somewhere on sites if you have several other use cases. And I will come back to this a little later. I think it's about you.
Looks like we used the right buzzwords for you. Okay. There have been demands, parts that we could solve ad hoc, luckily. Yeah, luckily there was some of them. As you already mentioned, it was a proof of concept. It was planned to have this proof of concept, and we had no idea what will happen after. So you see there has been some demands of the DFS aviation services that we were not sure who will take responsibility for it later on, and what steps we will take. What does this mean in an evolution of now already years of having the proof of concept, meanwhile a product-ready system? We are having access to network fiber all across Europe. This is here becoming really important. As you can imagine, there's parts of information that we will not share through the internet. You can add more information to that later. So we just get data directly into the public cloud that is capsuled and have an isolated access for the DFS and for the radar system. So based on our OpenStack infrastructure as a service, we have MetaCube, that is our Kubernetes as a service platform, and Sys11 is taking care of a 24/7 operation and availability of this Kubernetes clusters you're using. And the evolution is that step by step, within this proof of concept, you get an idea of what kind of building blocks, and these are the open source available building blocks that you all know, you may need. Using these building blocks with the best practices that Sys11 has out of the 15 years we have experience with it, means you can have up to a 24/7 operation, managed by Sys11 for parts of it, or either for the whole software stack. So in the end, this is the part where you guys put your software on top of all the layers using parts of our building block technology and doing what we have seen in the very beginning, making the actual product that someone, and in this case, flight controllers, are using to help us getting flights managed all over Europe.
Let's look a little bit about on the technology side. What is Phoenix Web Innovation about? So for us, it's a radar and flight plan system, and it uses the high-performance Phoenix tracker. That's what I've already explained. So the core part is still coming from our legacy product. We have not finished the transition towards a microservice architecture yet. So we have several parts of the old existing product reused, but within a container environment. So we are not at the end of the journey yet. That's what I have to state here. On top of that, we have built the web-based HMI. So this is the part which is completely new. I will come back to this on the next slide to show you a little bit about the system architecture. Together with our design and development team, we think we have created a really intuitive design. We've changed a lot of things, but couldn't change everything because as a controller, you are used to a routine and have to rely on your routine to provide safe operations every day. And that means a track label, so that means a flight position should always look the same, more or less. But we have tried to reduce clicks, for example, to make workflows easier for the controllers and reduce the training effort significantly for them. Usually, if you implement a new system on site, it takes days, sometimes weeks, to explain all the functionalities. We are down now to a level that we take like half a day for a controller to explain the system, and more or less everything feels intuitive, how to control all the functionalities and how to deal with the system. So that's great. And on the other hand, we have implemented just a reset button, so if the controller plays a little bit around, you can always go back to a default. That's great for the controllers as well, because they like to play with the system. For us, it was important to comply to all the Eurocontrol standards. So this is an European organization creating standards for how to use radar data, flight plan information, and everything else. They really like to create standards. On the one hand, this is great because you can easily implement parsers and stick to that standards. On the other hand, there are not many things or ways to deviate from these kind of standards because it's just a standard industry standard here. So you have to comply to all of them. But with the reuse of existing technology, that was an easy part for us because we had all the interfaces already implemented and could just easily reuse them within the new platform. One of the major parts was to reach a hardware and operating system independency. In former times, we had to buy large amounts of hardware, usually really expensive, to support all the applications. And after a couple of years, maybe 3 or 5 years, the hardware was already old and we couldn't get the same hardware. So we had to exchange operating systems, we had to exchange the whole hardware. That was usually a huge thing for all the operators of such systems. Now we are operating the system within a web environment. That means I just need a modern web browser and can easily exchange the hardware below, can have different operating systems, even use an iPad, for example, as you can see here. That's great for us, for our customers, and that helps us to create new business cases which we couldn't think of before. Cloud-based for us also means it's always and everywhere available. And this was a game changer for us as well. We had some use cases. For example, last year we had the flooding in North Rhine-Westphalia. I think everybody's aware of that accident. And we got the request by the government to provide a radar system to safely operate a lot of helicopters in a really small area. So within 4 hours, we could provide our system without having any infrastructure on site. That meant we used just a laptop, a mobile connection provided by the German army, and everything was set up for our controllers to operate the helicopters on site. And those use cases haven't been possible before. And that's, I think, a great advantage for such a system. Now let's have a look at the technology. So on the left-hand side, you see a picture of some of the radar stations. So we are using quite some different technology here. We have primary radar, secondary radar sources. We use ADS-B, multilateration, and a lot of others. Those sensors provide more or less position information of flying objects. Could be a drone, could be an aircraft, helicopters, everything which is flying around in the aircraft. Our tracker is capable of merging all those kind of information to just one track to show this to the controller. But here we have the difference between the ATC standards and the web-based standards. The web browser does not understand any information about radar or flight plan information. So we had to find a way to convert those information from the ATC standards into a different world. So we implemented a lot of converters in between. And that is on top of the legacy part, which is still running in just one container. That's, we have to state here. But between that, we're using a message queue. This is completely new. So we are transporting all the information via new standards. We use a web server where you get access. We have all those converters and the application on top. The application itself is relatively dumb, so we haven't implemented a lot of logic. It's more or less just an implementation of a display layer to present the information to a controller. So there is no need for having any calculations within the display. And that's why I could also use a sensor with a tracker included and just send like JSON messages from this kind of sensor directly to the display and have a separated presentation layer within the display. That wasn't possible before. Before that, we had to send all the position information via a tracker and have them merge into just one track. So a lot of different things happening here. The display itself is modular, so that means if someone already has a system on site with a tracker and we understand the output, for us it's easy to just bring the display, the presentation layer on site and have a web-based version with a system provided to the customer. It's easy to integrate new sensors, especially when it comes to drone detection. The usual sensors, primary and secondary radar, does not really work. So we have to integrate additional ones here. And with the modular design of the system, that's possible for us here as well. One of the use cases I've already explained, and we get a lot of requests to provide a system more or less immediately. In former times, it took us more than a month to provide a similar system with hardware, with operating system, with everything. And we had to send a technician out to some remote places to install the system on site and have them set up. With this setup here, it takes us between 1 and 4 hours because we have set up a lot of automation in the background already. That means I have to insert some of the coordinates, the position of the airport, give them a so-called ICAO indicator. That means the name, so to speak, of the airport and some other configuration parameters, and the system completely automatically sets up in the background in the cloud, and I can provide just a link and some user credentials to the operator, and so the operator is set up everywhere and always available. We had some requests for the European Football Championship last year, for example, in Munich. for those large events, the police forces and others observe the airspace. They implement a so-called restricted area above a stadium to protect them against unauthorized flights. And so they need a system to maintain safe operation. That means they have to observe the airspace at all time. And for such operations, we use these kind of systems nowadays. And that's everything new for us to have a mobile version of that. Let's sum it up a little bit and talk about some additional aspects of the system. So hardware and operating system independency, that's what I've already mentioned, important thing for us. We have no restrictions when it comes to the number of controller working positions. That means the positions where a controller could work. In former times, we had maybe 1 or 2 positions that was all related to hardware, KVM extenders, so it was limited. Now I can open as many controller working positions as possible within a web browser and have them on a standard desktop machine, laptop, iPad, whatever, so no limitations when it comes to that. I can have remote access, so for all our technicians, that's great. They don't have to drive to any remote places, and I can tell you we have some of the airports, some down in Memmingen. This is close to the Austrian border. We have some really in the northern parts, so if you have to drive to all of them, that takes quite a long time. Nowadays, they have a centralized maintenance concept. That means they have directly access to all the customer instances within the cloud environment and can easily change things like map updates. In former times, we had to provide a CD or a USB stick to someone on site, inserting this stick to do a map update. Nowadays, we just let the customer know that we have done a map update. Please press F5, and that's it. Yeah. So a little bit easier than what we have had before. Of course, with the cloud provider, you get some of the services of the platform as well. You don't have to keep an eye on the platform, on the regular updates, so they're doing all the stuff like the security updates and everything. We are not the experts in maintaining a cloud platform. That's not our business. We are operating ATC products, and we are providing air traffic services. That's our main business, and I don't want to keep an eye on all that other stuff. That's why we have them on board. That's always great. The deployment chain has changed completely for us as well. That brings some advantages, but also problems. In the background, we have a regulator. For all the changes we are implementing within ATC software, we have to get an approval by our regulator. With a new deployment chain, I could easily provide a new update every minute, every hour, run some automated tests, and make sure that everything runs smoothly and I have no problems included in the software. All the processes with our regulator are different. They expect us to ask them weeks in before, maybe months in before, to implement a new change. So that's the part we have to work on with the regulator to change also these kind of administrational processes. Because it doesn't make sense if you have, on the one hand, a cloud product and a deployment chain to provide products every minute, make a change. On the other hand, you have those kind of regulations. And usually a product gets updates maybe once or twice a year. That's the regular cycle at the moment. And now with that kind of product, we could do this every day if necessary, provide all the customers with the same functionalities, and that was not possible before. However, we have to convince the regulator to follow this kind of approach, and within EU legislation, it's not yet included. That means we have to do some lobbyism as well to make them aware about the advantages and also about the challenges we are facing here, and include them in the whole process of providing these kind of systems.
So for all of us thinking cloud native, most of us thinking cloud native all of the time, it's obvious, why should you ship hardware somewhere and do it like over and over again? After 3 years, you have to ship new hardware, sending an engineer, whatever. So for us, it seems like really obvious, but it's not. There are lots of customer cases out there that are just getting into Kubernetes, getting into cloud native, and the advantages of it. Yeah, that's it. So, and it's not about the time of your engineers. It's about saving money as well, because in the end, your customers save money. You save money. All of them in the whole supply chain. Yeah.
But the platform also comes with some of the problems. In former times, our engineers could easily access the hardware on site, could look at all the cables, check a hard drive and everything. Now we have the Kubernetes magic. So we have many, many abstraction layers in between our application and the real hardware. So we had to convince and always have to convince the technicians to work with a cloud platform. That is a big change for them. They are not able to do the debugging they've done before. So you have to do a lot of change management on the other side as well. This is not just a technical thing. For us, it changes all the processes to work with the regulator, how to maintain a system, how to operate the system, how to access the system, almost everything. We had like an encapsulated world before. Now we have a lot of interfaces to the real world. That changes a lot of things when it comes to cybersecurity and other things. We had no ideas what this would mean for us before we had implemented such a cloud system. And also connectivity. In former times, we just used our connections between centers and towers, and now we had to implement a direct connection from our centers towards the cloud. That took us a year to work with some of the telecommunication providers just to provide a separated line to make sure that it's safe and everything. We had to talk and talk and talk about days, weeks to make that happen. And yeah, that's also new for us because we couldn't think of those things before.
Yeah, still in between of the proof of concept.
You're still working on that.
Challenges left, so it's not that easy. You have been demanding all the time, questioning everything twice, looking deeply into it, right? And that was good for both of us. So yeah.
And we still have some issues to solve when it comes, for example, to how to provide radar data into a cloud environment. We use UDP, for example, because first it makes sense to send radar data just as the UDP broadcast into a cloud. He told me it's not possible to send UDP to several Kubernetes clusters. So we said, okay, we have to find a solution. We need a UDP load balancer and everything. That's where the old world meets the new world, and you have to find ways how to cooperate with both sides. And that's, I think, one of the important parts here, why we have chosen a cloud provider which could support us within the proof of concept and now within the operations.
That's the moment where we invite you to discuss why a cloud provider don't want to have UDP broadcasting within his clusters. And this is what we discuss at our booth, if you want to do it.
I think that's it from our side. We've seen the 3 minutes.
Hopefully there are some questions left.
Okay.
Thank you very much.
So yeah, we have a few minutes left. Thank you very much for the talk. We have a few questions, if we can have them on the screen, perhaps. Should be here any seconds.
No worries.
And there, here they are.
Good one.
So how do you manage availability, especially with the message queue? Do you operate multiple regions? Yes and no. At the moment, we are still within the proof of concept. So we have just one region. However, especially with the regulator, we have to think about a different concept. So we need more redundancy, we need more clusters, we need to have geo-redundancy. So that's what we are discussing at the moment and how to manage that within our application.
This is where we have to jump in as well. Yeah, this is not only about regulation for the DFS. This is becoming part of this 11 as well.
Do you have a better availability in the cloud than before? I don't know. We haven't measured that. It's different. Within the cloud environment, usually I don't see that something has went wrong. It just heals itself. On site, when I have to exchange hardware, I know exactly that something went wrong and I have to replace it. So maybe yes and no. When you create a new system in 1 to 4 hours, what does this entail? Creating new clusters to process the industry, it's a standard data stream your customers provide. Well, we have created a kind of recipe how to create a new system in the background. So that means I have to insert just a couple of parameters to set up the system. A large part of the system is standard and generic. That means like 10% needs to be configured, rest is standard. And that's why we can easily and fastly provide a system to the customer. Yeah, the last point. Thanks for the compliment. How do you manage observability of such a complex system? Yeah. That's also really a challenge for us. In former times, we had implemented a monitoring system for each of the systems and the parts of the systems, and could see a red or green button on site and knew exactly that the system was running correctly or not. Now we have to create or use some of the services the cloud provider provides, or have to create services as well, using Elastic Stacks and other things to collect log files and provide them at the end to the technician to get an overview if the system is okay or not.
Just choose your question. We have time. We have a few minutes left, so it's okay.
Yeah,
go ahead.
Some time left. I think I'll pick like how you secure your containers and Kubernetes. Like we knew that this question will come. Of course, this is a multi-layer problem. So from our point of view, customers using a public cloud. For that special case, you first think like this might be a problem. You have other customers on that platform, and so you may have a bad neighbor on it. We can solve that. We kind of capture everything, isolate them, have like a so-called private cloud within the public cloud without losing any feature sets. This is the first step that is possible for everyone or every of our customers. If you're getting to a special size or want to do the proof of concept, especially for that kind of case. And then further on, it's going up to the layer of the platform that we are taking care of, and we are securing our network stack, the infrastructure stack, the Kubernetes stack. This will take a long time to get into detail, and I might be the wrong person for that, to get into the technical details. And afterwards, this is where the magic happens, to kind of combine the software stack, the building blocks that we have, and mesh it with the software stack you guys have, and getting a pipeline that we all agree on and really have a continuous integration, continuous development that we can test for production setup, and in case something went wrong, roll back immediately.
So first question, your legacy system in a container, is it on KubeVirt or native? It's on native, so that was easy to answer. How do bridge the gap between the velocity of cloud native dependencies and regulator-paced update patch cycles? Not yet decided. We are still in talks with our regulator how to support our deployment chain. And last one, so this did make it from proof of concept to prod. Yes. Where and to which degree? So we have to distinguish between information systems and air traffic control systems. At the moment, it's in the state of an air traffic control systems. The rest has to be cleared up with the regulator, and then it can be used as an air traffic control system as well. And how is the DFS aviation service? Oh, gone.
Gone. Time's up.
No worries.
Any more? No. Otherwise, you'll find us at the booth at this 11. Stop by. Thank you very much.
Thank you so much for answering all these questions.